I think I got it. So for example, right, this part is plus 3, this part is plus 3, plus 4. Then how can you offset to 0? Because this whole thing is plus 4, then you need another minus e. This whole thing is equal to e, and you need another minus e. So then you can try to derive for the initial difference sequence. So this whole thing is d. This thing is s. This thing is d. But in order to get d, right? In order to get d, so here's 0. In order to get d, here's 0. Here, in order to get d, here's 0. In order to get d, here's 0. Then in order to get minus e, you have to be minus e plus d. This part, right? Then this part is e. This is 0. Because in order to get 0, you need in order to get 0, this whole thing, let's take a look in here. This whole thing together minus d is minus e, right? This whole thing is minus e, pre-sum. Then you need minus e to get 0. That's how we derive this function, which is the initial sequence difference, which is L plus L position plus S, L plus 1 position plus RD minus S, R plus 1 position is this minus D plus E plus D, and R plus 2 position is E. That's all. Continue. This is a question that you have V, volume and position, and you also have M, number of M, like this is a line number. This is M, is how many percent drop into the water, and here is a water wave. Here's a water wave, and if you drop and will get splash, is the range till here is x minus 3v, and this is the right range is this one. And offset, what is the offset? Is to avoid boundary checks.